Hey, tech enthusiast! Today I'm going to show you how to perform remote backups on a Linux system using Rsync. In your chmod window on your local machine, log into your root account and then type in the following command to generate a new RSA public and private key pair. A public and private key pair is crucial for secure communications in systems like SSH, enabling authentication and encryption. Next, we are going to modify the SSHD configuration file to use a custom SSH port. This enhances security by obscuring the default port. It also reduces the risk of automated attacks against well-known ports, such as port 22, the default port utilized by SSH. These changes add an extra layer of defense against unauthorized access, as potential attackers must discover both the customized port and possess valid credentials to establish an SSH connection. Make sure to set a very strong password. Now we're going to navigate into the .ssh directory and modify the configuration file. Customizing this file offers a few benefits, such as a friendlier and personalized SSH experience. By adjusting settings like hostname, user, local forward, connect timeout, and more, we're making remote access smoother and more user-friendly. The indicated IP address is going to be the IP address of the remote machine, and the user is going to be root or another user that you're planning to connect to. We are going to use port A73 for local forwarding, since that is used by Rsync by default. When using SSH with port forwarding, we are creating a secure and encrypted tunnel to connect to the remote machine. The identity file will point to the private key that you generated earlier. Make sure that you're typing in the path correctly. We will set connect timeout to 30 seconds. Now that we're done with the various modifications, we are going to restart the SSHD service. Up next will be the configuration of port forwarding. We will set it up on the router that is connected to your remote computer so that we can connect to it remotely. The user interface might be a little different for you, but the approach is going to be very similar. Under port forwarding, add the IP address of the remote computer with its associated port, which is going to be TCP 2525. Now that we've added the port forwarding rule, we're going to transition to the remote computer and make a few SSHD configuration changes. Log in as root and then navigate to the etc SSH directory. Here we're going to open the SSHD config file and make the same changes that we've made on our local machine. Since we are permitting root login and password authentication, make sure to set a strong password on your root account on your remote machine. The command for how to change a password will be listed in the description. Now that these settings are in place, we're going to enable our firewall and add a rule to it. I chose UFW to serve as the defense layer to protect the system from unauthorized access. Here, we're specifying to allow SSH traffic on port 2525. If you're receiving, skipping, adding existing rule, then it means that this rule was already added to your firewall. Lastly, make sure that your firewall is reloaded and then move on to installing the OpenSSH server. Once you're done with the install, switch back to your local machine and verify the status of your firewall. I'm using IP tables on this machine. Since IP tables is up and running, there's no need for me to enable it. If it's not active on your system, use the command systemctl enable IP tables. Now insert the following two commands to allow inbound and outbound TCP traffic on port 2525. To make IP tables rules persist across reboots, you typically need to save them to a configuration file and ensure that this file is loaded during the system startup. If you plan to do that, then make sure that the rules are reflected in the rc.local file. Now we are going to switch to the remote computer. Since I'm on a Raspberry Pi system, I will have to enable SSH through the configuration tool to be able to establish a remote connection with this computer. If you are on a different Linux distribution, then you may not have to do this. Now that there isn't anything left to do regarding SSH on the remote computer, we're going to switch to the local computer and attempt to connect to the remote computer using password authentication. This will let us know if SSH is set up correctly. Here, put in the root password of your remote computer. If the password you have entered is correct, then you should be able to get in. Now, we're going to transmit the public key that we've previously generated to the remote computer for seamless public and private key authentication. If you are encountering any issues during the key transmit, make sure that the permissions of your public and private key are set to 600. The command to how to do that is in the description. Now, we are going to attempt to authenticate to the remote computer with our private key. This approach does not prompt you to log in with a password, which reduces the risk of unauthorized access. It is also very convenient. Do not append .pub to ID_RSA since we're not using the public key, we're using the private key to authenticate to the remote computer. The remote computer is going to use the public key to verify the authenticity of the private key. Since public and private key authentication worked, we're now going to try to send some data to the remote computer using the rsync command. The parameters -av allow you to preserve the permissions of the files that are being transferred, and it also helps you see the progress of the transfer. The parameter -e specifies the remote shell that we're going to use. In our case, it's SSH. -i is representative of the private key, and -p represents the port that we're going to use for this backup. Here, I have indicated the path to the folder that I would like to back up. It could be any folder, followed by the remote destination. If you are going to back up to the same destination, make sure that the media and backups directories exist on your remote computer. Now, I am making sure that the command looks good before I initiate the backup. I am also making sure that the folder that I'm planning to back up, titled For YouTube, exists. Since the folder exists, I can initiate the backup. The backup was a success. Now let's switch to the remote computer to confirm that the files were received. I am going to navigate to the media directory and then to the backups directory and verify that the folder titled for YouTube is actually there. I will then go inside that directory and confirm that its associated files are present as well. There were 2 files stored in that folder and both of them have been transferred. This indicates a successful transfer. We are now going to switch back to the local machine and add 1 file to the folder titled for YouTube. There are now 3 files instead of 2 files in that folder. Next thing we're going to work on are incremental backups. Navigate to your Documents directory and create a folder titled Scripts. Now navigate to your Scripts folder and create a shell file titled Backup Script. I created a script that allows for efficient incremental backups across different machines or file systems. This script is going to be available in the description section of this video. That way, all you have to do is just copy and paste it. And here, all you have to do is modify the local source directory and the remote machine details. In order to run this script, we will have to make sure to give the root user the execute permission on this file. chmod 744 will grant the root user execute permissions. We are not going to execute the script yet. First, we are going to switch to the remote computer and create 2 folders titled Current and Incremental Backups. Make sure that these are created in the media/backups directory. Now that the folders are created, switch back to your local machine. We are now ready to run the script. The script ran successfully. Now let's just make sure that the new data was received. Navigate to the incremental backups folder and then to the folder with today's date. Navigate to the folder you intended to backup. In my case, it's titled for YouTube, and make sure that all of its contents are present. Now navigate to the folder titled Current and perform the same verification process. This folder points to the incremental backups folder and it's there for easy reference. When you're done with the verification, switch to your local machine. Now I am going to open the Systems cron tab, which offers the convenience of automating repetitive tasks on a scheduled basis. This improves efficiency and it eliminates the need for manual intervention. In this line, I am ensuring that the script runs at 10 o'clock in the morning and at 10 o'clock at night every day. Everything we've covered in this video today contributes to successful backups. If you found this video helpful, drop a like and subscribe for more tech insights. Thank you for watching.